Hi, this is going to be a quick probability primer to help with the project about Deuce, the project called Deuce. Okay, so we're going to talk first about flipping a coin. So when you flip a coin, there are two equal possibilities, heads and tails. So let's say we're going to flip two coins. I'm going to flip a coin twice in a row. So my possible outcomes would be heads and then heads, heads and then tails, tails and then heads, or tails and then tails. 4 possible outcomes. So the probability of heads and then heads is 1 out of 4 total outcomes. There are 4 possible outcomes. One of them is heads and then heads. So the probability is 1/4 of the time you'll get heads, heads. Okay. The probability that you get tails, tails is also 1/4. Now, probability that you get heads, tails, or tails, heads. So the probability of a split. Heads once and tails once. There's 2 ways that can happen, heads, tails, or tails, heads. Well, that's half of the possibilities. 2 out of the 4 outcomes have a split outcome, tails and heads. Okay, so this is how you can calculate probability. One way to calculate probability is to write out all the possible outcomes, write out every possible outcome, assuming they're all equally likely, and we call this the sample space. And then you can calculate probability by how many of the outcomes are desired divided by all the possible outcomes. Okay, another way, a little shortcut you can use to calculate probability is if I want to do the probability of heads, heads, I can think about it in terms of 2 independent events. So first you're going to flip the first coin, and the probability that you get heads is 1/2, 1 out of 2, because there's only 2 outcomes. Okay, and then then you're going to do it again, and the probability that you get heads again is also 1/2. So there's this law of probability that says if 2 events are independent, which means the outcome of one does not influence the outcome of the other, then if you want to know the probability that both things happen, you can multiply the probabilities of each one separately. So you can do the probability of heads, heads, that's the probability of heads times the probability of heads again. 1/2 times 1/2 is 1/4. So it's the same answer we got when we just looked at the sample space. So if I want the probability of heads, tails, probability of heads is 1/2, the probability of tails is 1/2, you multiply them and you get 1/4. Okay, the probability of tails, heads, same thing. 1/2 times 1/2, you get 1/4. Okay, another rule about calculating probability is that if you want to determine the probability that one thing or another thing happens versus and. So for and, you use multiply. The probability that you flip heads the first time and you flip heads the second time, you multiply. Okay. But if I want to know what's the probability that I get heads, tails, or tails, heads, for an or, you add the 2 probabilities. So the probability that we get heads, tails, or tails, heads, that's the probability of heads, tails, plus the probability of tails, heads. So for or, we can add the 2 probabilities. So this is 1/4 plus 1/4, which is 1/2, which is the same thing we got when we wrote out the entire sample space. Okay, so to summarize, If you want to calculate the probability of event A and event B happening, both happening, you multiply the probabilities. Probability of A times the probability of B. If you want to calculate the probability of event A happening or event B happening, you add the probabilities. Probability of A plus the probability of B. Okay, for an example, if we roll a die, I want to find the probability that an even number is obtained. So I can do this two ways. I'm going to do it the write out the whole sample space way, and I'm going to do it with the shortcut. Okay, so the sample space, which I often shorthand SS, all the possible outcomes are 1, 2, 3, 4, 5, and 6. So the event that I'm interested in, so the probability that I get an even number, that means the probability of 2, 4, or 6. Okay, those are 3 out of the 6 possible outcomes. So the probability I get an even number is 1/2. All right, another way to do this is to say, what is the probability I get an even? That's the probability of 2 or 4 or 6. So it's equal to the probability of 2 plus the probability of 4 plus the probability of 6. So 1 out of 6 plus 1 out of 6 plus 1 out of 6 is 3 out of 6, or 1/2. Okay, another example. We have a die is rolled and a coin is tossed. Find the probability that the die shows an odd number and the coin shows a head. So I want probability odd and heads. Okay. So that word and means I can multiply the two probabilities. So this is the probability that I get an odd number on the die times the probability I get heads. So the probability I get an odd number on the die is 3 out of 6, or 1/2. The probability I flip heads is also 1/2, so I multiply them and I get 1/4. Okay, here's a little bit of a trickier one. We have a jar that contains 3 red marbles, 7 green marbles, and 10 white marbles. If 2 marbles are successively pulled from the jar without replacement, what is the probability you get a red and a white in either order? You pull a red and then a white, or a white and then a red. Okay, so I want the probability of a red and a white. I'm going to put that in parentheses, red and white, or white and red. So that's going to be probability red times probability white plus probability white times probability red. All right, so calculating these probabilities is a little different than it was before because we are not replacing. So when I calculate the probability that I pull a red first, okay, I know that there are 3 red marbles out of 20 total marbles. Okay, but then if I'm going to pull a white next, there are only 19 marbles left because I already took a red one out. So, and 10 of the 19 are white. Okay. Or this is a totally separate outcome here. The probability of white is 10 out of 20. If I pull a white first, there are 10 whites out of 20 total marbles. And then if I pull a red next, there are only 19 marbles left. 3 of them are red. So I'll just do this multiplication. I get 30 over 20 times 19, 380. Same thing over here, 30 over 380. So 60 over 380. And that reduces to 3 out of 19. Okay, last example. This one is closely related to your project. So in a tennis match, the probability that you win any given point is 0.728. That's like 72.8% chance that you're going to win any given point. So what's the probability that your opponent will win any given point? So two probabilities, the two probabilities have to add up to 1. So I'm just going to do 1 minus 0.728. And you get 0.272, or 27.2%. So there's a 72.8% chance you'll win any point and a 27.2% chance your opponent will win any given point. The two probabilities, because those are the only possibilities, have to add up to 1. All right, what is the probability you win the next 2 points? So that's the probability you win and then you win again. So that and means multiply, right? So the probability you win is 0.728 and you win again, so you multiply 0.728. So that is 0.5299. So we're just going to call it about 0.53. Use the squiggly equal signs because I'm rounding. It's approximately equal to 0.53. So there's like a 53% chance that you'll win the next 2 points in a row. What is the probability that you split the next 2 points, you and your opponent? So you win one and they win one. Well, there's 2 ways that can happen. We're going to look at the probability that you win and they win, right? And I'm going to parenthesis that. You win and they win, or they win and then you win. Okay, so there's 2 ways that you can split the points. Either you win and they win, or they win, then you win. So this is going to be a multiplication. The probability that you win and then they win is 0.728 times 0.272. That's the probability you win times the probability that they win. Or that's add, they win 0.272 and then you win 0.728. So the or got an addition, the ands get multiplication, and this comes out to about 0.396. So there's a almost 40% chance that you will split the next 2 points.